Hello and welcome to PE Academy. So in this video we are going to be looking at superposition principle in Coulomb's law. So we're going to look at what the principle states, the formula associated with it, and some examples to explain what superposition in Coulomb's is talking about. So now let's start with the Coulomb's law. Alright, so the principle states that if there are n charges, so Q1, Q2 to whatever number, located respectively at R1, R2 and to any number, it says the resultant force, this, on the charge located at point R is the vector sum of the forces exerted on charge Q by each of the charges Q1, Q2 till Qn. Alright, so this is too many English. Let's try to break this down to see what it's saying. So in the previous videos, we've looked at Coulomb's law, where we have it as F is equals to Q1, Q2 over 4 pi E naught, and then the square of the magnitude of the force, let's just call it AB, all square multiplied, now this for vector forces, multiplied by the unit vector RAB over the magnitude of that vector RAB. Now this is when you are having two charge, exactly between two charge Q1 and Q2, and maybe Q1 is acting upon Q2, maybe Q1 is acting upon Q2, or maybe Q2 is acting upon Q1, exactly. But what if we are having a situation whereby we have a particular charge, let's call this charge Q1, and then we have other charges. So let's call this is Q2, Q3, and then and then Q4. So this is Q4 acting upon Q1. So now with this diagram that we have here now, let's look at it with the principle. So the principle states that if there are n charges Q1, Q2 to whatever, so in this one now we have Q1, Q2, we have, okay, so let me just rename renumber the charges. So if this is point Q, and then we have this to be Q1, Q2, and then Q3. Okay, so it says located at respectively at R1, R2, and R3. So this one is located at R1, and this is located at R2, and this is located at R3. Exactly, so that's the coordinate. Okay, so the resultant force Fn on the charge located at point R. So that means the resultant force acting at this point where we are having it to be Q and the coordinate is R, okay, is the vector sum of forces exerted on charge Q by each of the charges Q1 and Q2. So what it's saying is that the resultant force acting on this charge Q is the sum of the resultant force acting on each of this charge to this point. So what that is saying is that means the resultant force F is saying that F is equals to Q1. So let's just take this to be R naught. That's Q. Let's call this Q naught. So let's just call it Q naught, ordinary Q. Q1. So that means between this, the force exerted here, and Q1 over 4 pi E naught, then R naught 1 square multiplied by R naught 1 over the magnitude of R naught 1 square. So there won't be square here, exactly. So plus, that is for this part here, plus Q naught Q2, that means for this, the force exerted here, over 4 pi E naught and the magnitude of 0.1 square multiplied by, this will be 2 O2, that's the unit vector, over RO2, that's the magnitude, plus, now for the third one, Q0 Q3 over 4 pi E0 square of the magnitude of 0.3 square multiplied by the unit vector 0.3 over the magnitude of R 0.3. Alright, so you will continue in that manner. So let me just put this in brackets so that, or in parentheses, so that you can really see the difference there. So you continue till the number of charges. For example, in this now we are having just 3 charges acting on this Q0. Exactly. So you continue in that manner. Now this equation that we are having here can also be rewritten as F0, because if you should notice what we are having here, that this is common to all, and then this 4 pi E0, it will be the same thing. The only difference there is, so let's just factor it out. So if we are to factor it out, we are going to be having Q0 over 4 pi E0 all into brackets Q1 over the magnitude of the charge Q1 to Q0 all square multiplied by the unit vector from Q1 and the unit vector between Q1 and Q0 over the magnitude plus Q2. So doing it like this will actually make your calculation much more easier, over the magnitude of R02 multiplied by the unit vector over the magnitude then plus Q3 over the magnitude of R03 square multiplied by the unit vector 03 over the magnitude of 03. So don't forget all the bar when necessary. Alright, so this will be the case if you have 3, just based on this diagram that I'm having here. So if it is 4, if it is 5, you should know that it will continue like this. So alright, so I hope you got the concept between the superposition when it comes to Coulombs. Now this superposition is just similar to the one you have in circuit theory, where if you have multiple sources, if you have a circuit and you are having multiple sources, where you you short circuit or you open one source and then you use it to get the current or passing through a particular element, exactly, and then you look for the resultant. So it's just the same idea, the same principle that is also working here when you are dealing with superposition principle in Coulombs. So with all this explanation, in the next part we are going to be looking at example to understand how to really apply some of this, this particular formula in answer question under superposition principle in Coulombs. So if you find value in this, please don't forget to give it a thumbs up. Subscribe to the channel if you are yet to. The subscribe button is at the lower right somewhere here. Use that red square box with the subscribe written on it. So just subscribe, and then I'll see you all in the next part in example 1. Alright, thank you.